First review problem, I'm going to use the definition of derivative to find the derivative of our y function here with respect to x. So we need to use the limit definition of derivative, which is the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. So in this case, my f of x function is a 3x squared plus 2x plus 3. So f of x plus delta x is 3 times x plus delta x squared plus 2 times x plus delta x plus 3 minus 3x squared plus 2x plus 3 in brackets divided by delta x. So now what I'm going to do is do some algebra, expand out the parentheses, combine like terms, use my distributive property, cancel out like terms, and then simplify. Simplified limit is the limit as delta x goes to 0 of 6x plus 3 times delta x plus 2. So now that I got rid of the division by 0, I can direct substitution in, replace delta x with 0, end up with my derivative is 6x plus 2. In example number 2, we're going to find the equation of a tangent line to a function at the given point. So what you need to do first is you need to find the slope of the tangent line. The slope of the tangent line is the derivative of the function. So we're going to repeat what we did in step 1, but this time using x cubed minus 2x squared plus 3x minus 1. Therefore, our simplified limit as delta x goes to 0 is 3x squared plus 3x times delta x plus delta x squared minus 4x minus 2 times delta x plus 3. And now I can do direct substitution, replacing every delta x with 0. Simplifying the equation down, I get my derivative of y with respect to x is 3x squared minus 4x plus 3. Okay, that gives us a derivative, our equation of all of the tangent lines of our function. So I'm going to put it up here so that we have this to look at. But that does not actually answer the question. I need to find the next step I need to do is evaluate my derivative at x equals 1. I do this by replacing every x in my derivative equation with 1 and simplifying down, which will be equal to 2. So the slope of my tangent line at x equals 1 is 2. Last thing I need to do is I need to find the point on the graph through x equals 1. So I can find this point by, I have the x value, so I need to find the y value at x equals 1. And I do this by substituting in 1 in place of every x in our original function equation. F of 1 is equal to 1. Now I know the point of tangency, which is the point 1, 1. Our step 4 in this type of problem is now we're going to find the equation of the tangent line by using the slope we found in step 2 and the point we found in step 3. So my slope will be 2 and the point I'll be using is 1, 1. I'll plug this into y equals mx plus b. So y is 1. Slope is 2, x is 1. I'm going to solve this equation for b. I get b is equal to a negative 1. That means my equation of my tangent line is y is equal to 2x minus 1. This example, we're going to find the average rate of change of the function over the given interval and the instantaneous rate of change at the leftmost point. So let's start with finding the average rate of change. First thing you need to remember is when you're looking at average rate of change, you're looking at the slope of the secant line, or the change in y over the change in x, or y2 minus y1 over x2 minus x1. In function notation, this is f of x2 minus f of x1 divided by x2 minus x1. So the first thing I'm going to have to do in this example is I need to figure out my y value at each of these points, or I can directly substitute it into my equation using my f of y2 minus f of y1. So that's what I'm going to try this time. So f of y2, I'm going to replace every x with negative 3 over 2 minus f of x1, replacing every x with negative 2, divide by negative 3 halves minus a negative 2. Using my rules of algebra, I'll simplify this compound fraction as follows. For my average rate of change over the interval from negative 2 to negative 3 halves would be negative 7 halves. Next, we were asked to find the instantaneous rate of change at the leftmost point, and this is by the derivative. So using our definition of derivative, I will replace every x with x plus delta x, then replace and then minus f of x over delta x, and then use my rules of algebra to simplify this problem down. Now we're ready to evaluate the limit by replacing delta x with 0, and we get our derivative is equal to 2x. So we evaluate that derivative at our leftmost endpoint of negative 2, and we get the instantaneous rate of change is negative 4. For our next example, we're going to take it one step farther, and we're going to find the equation of the secant line and the equation of the tangent line. So first, let's start with finding the equation of the secant line. So to find the equation of the secant line, you're going to need to do a few things. The first thing you'll need to be able to figure out is you need to find your average rate of change, or the slope of the secant line, by using our change in y over our change in x formula. Since we already know our y values, I'm going to substitute my two y values in, y2 minus y1 divided by x2 minus x1, and simplify this down. The slope for the secant line will be negative 7 halves. Our step 2 is we're going to find the equation of the secant line using the slope we just found in step 1 and a point. And it doesn't matter if you choose which point you choose. I'm going to choose the negative 3 and 2 because I think it'll be easier to work with than the fractions. But if you choose the second point, you will get the same answer as I do with the first point. So the key is find the slope of the secant line and one of the points on the secant line. Since I did y equals mx plus b last time, I'm going to use the point slope form this time to simplify it down. So I have y minus 2 equals negative 7 halves, x minus a negative 3, and then simplifying down. We've answered the first question. The equation of our secant line will be this: y equals negative 7 halves x minus 17 halves. Next, we were asked to find the equation of the tangent line at the point negative 3, 2. We'll start by finding my derivative, which is the limit as delta x goes to x of x plus delta x squared plus 2 times x plus delta x minus 1 minus x squared plus 2x minus 1 all over delta x. And then I'm going to simplify this using algebra. Gives us a derivative of y with respect to x of 2x plus 2. And if I evaluate this derivative at the x value of our point of interest, which is -3, I find that my slope of my tangent line at -3, 2 is -4. Now that I know the slope of our tangent line and our point of tangency, I'm going to find our equation by using y equals mx plus b, placing y with 2, slope with -4, x with -3, and solving for b. For my equation, my tangent line is y equals -4x minus 10. Now let's review how to find what intervals a function is continuous and the intervals in which a function is differentiable. To figure out this function is continuous, we need to look and see if the limit as the function approaches 2 from the left is equal to the limit as the function approaches 2 from the right, and if the function value exists at 2, and if that limit at 2 is equal to the function value. So here I found the limit as x approaches 2 from the left is -1. Now as limit as x approaches 2 from the right is also -1. Therefore, we know that the limit as x approaches 2 of f of x is -1. So the limit exists at that point of division. So next thing I need to find is the function value at 2, which is also -1. So since my function value equals my limit value, I know it's continuous at 2. I also know because the top function is a linear function and the bottom function is a quadratic equation, that both of those functions are continuous everywhere over their domain. So this means that this function must be continuous from -infinity to infinity. For part B, we were asked to find the intervals in which this function f of x is differentiable. So f of x, we know that the top function is linear, the bottom function is quadratic, and so those are continuous everywhere, and there's no sharp corners or cusps or vertical tangent lines in those two graphs. So the only point that I have to worry about is 2. So I'm going to figure out my derivative as x approaches 2 from the left and my derivative as x approaches 2 from the right. And I'm going to use the alternative form of the definition of derivative this time, which is above. So from the left, I will be using 5x minus 11 minus, substituting in 2 in place of every x. For f of 2, I use the bottom equation because that's the one in which it's or equal to. Do not use the top equation. Now I'm just going to simplify down and see what my derivative equals. Derivative from the left of 2 is equal to 5. Now I'd find the derivative from the right of 2 by doing the limit as x approaches 2 from the right of x squared plus x minus 7 minus -1, which I figured out before was when I substitute in f of 2, divided by x minus 2, and simplify this equation down. Our derivative from the right of 2 is also 5, so since the derivative from the right is equal to the derivative from the left, that means our derivative exists at that point. So therefore, the interval in which this function is differentiable is from -infinity to infinity. Example 6, we're going to figure out what letters of a and b will make this function differentiable. First thing you have to recall is that in order for a function to be differentiable, it must be continuous. So the first thing I'm going to do is figure out which values of a or b will make this function continuous to get one of our equations. So to figure out if it is continuous, I'll say the limit as x approaches 2 from the left of f of x, which would be the bottom equation, x squared minus 6x plus b, must be equal to our function value at 2. So using direct substitution into the limit equation, we get 2x minus 6 times 2 plus b has to equal to, again substituting into the top equation, a times 2 squared plus 10. Simplifying this equation down and getting a plus b on one side. We find that -4a plus b must equal a positive 18. I'll write this equation up here so I can remember it for our next part. Notice I don't have to figure out the limit as x goes to 2 from the right because it gives us a meaningless statement. We end up with ax to the 2 squared plus 10 is equal to a to the 2 squared plus 10, which doesn't help us any at all. So I can't use this equation, so that's the reason why I have to use my differentiability to get my second equation so I can solve for either the a or the b. Next, I'll figure out if my function is differentiable at x equals 2. Now, usually in class, we've been using our alternative definition of derivative to do that. But in this case, with the a's and the b's, it becomes way too complex and way too difficult an equation to solve. So instead of using my alternative definition of derivative, I'm going to use my definition of derivative to get the derivative of the top equation, ax squared plus 10, and then the derivative of the bottom equation, and I'm going to make a piecewise defined definition of derivative, piecewise defined derivative, and then I'm going to look at those and set my limit to the left and limit to right equal to each other to figure out my second equation. So using our definition of derivative, we're going to find the limit as delta x goes to 0, and of the top equation, ax squared plus 10. And then we're going to simplify this down using our rules of algebra. So for our derivative function, f prime of x, I'm going to make a piecewise function, and my new top derivative will be 2 times ax, and this is when x is greater than or equal to 2. And now I'm going to repeat this process, the x squared minus 6x plus b equation. Derivative for x is less than 2 would be the equation 2x minus 6. So I have my derivative defined by a piecewise function breaking down at 2. And so for my derivative to exist at 2, the derivative from the left must equal the derivative from the right, or I could say that 2ax must equal 2x minus 6. This equation for a, I get a is equal to negative 1/2. Now that I have a is equal to negative 1/2, I'm going to go back to that red equation I got from my continuity, the negative 4a plus b equals 18. Replace a with negative 1/2 and solve that equation for b. Therefore, my a is negative 1/2, my b is 16.